What do you see in the picture behind me? Obviously, satellite image of the world at night. You see very clearly where people are living. But do you see, when looking at India, that India has a much higher population density than looking at the United Kingdom? And take a look up on the right-hand side of the picture. The Korean peninsula at night turns into an island of South Korea and a big black hole where lights don't come on in North Korea. Do you see that the huge population centers we have in Nigeria and the Democratic Republic of Congo? Now imagine what this picture would look like, or will look like, as development is occurring across the world when the rest of the world gets up to living standards similar to what we have here in the West. Not only will a lot of places on the planet turn bright at night, but the world would need a lot more energy. Which energy sources are powering this today? Here you see a distribution of all the energy sources that are giving us the lights, that are allowing our cars to drive and whatever. We can see a promising growth of new renewable sources of energy on the top. And we know that the developed world has largely plateaued in energy consumption, but the prosperity development in the developing world is really so vast that the renewable energy sources that we are developing at large scale today will not be able to cope with it for the next few decades. In order to keep the lights on, we will rely in this world hydrocarbon sources like oil and gas, or fossil fuels, other fossil fuels like coal. Now you may say, well, okay, this is business as usual, nothing dramatic is going to happen in this space here. But if you look at the reality for the producing oil and gas reserves in the world today, to maintain the production that you see on the chart here, we will need to replace 8% of that production with new sources every year. That means full replenishment of the hydrocarbon energy sources over a 10-year period. The history of oil started around mid-19th century, 1850, 1849 in Baku in Pennsylvania and other places. At the beginning of the 20th century, we really saw it developing into an industrial scale. And during the 20th century, we went from rather primitive methodologies, being onshore, moving to more modern technologies, moving to more advanced technologies for seeing the subsurface and understanding where the oil is and developing it. We moved from onshore to shallow waters to deeper and deeper waters. Today, we are drilling wells at thousands of meters of water depth, hitting reservoirs or targets that are further several thousand meters under the seabed. And the industry is doing amazing things. Just to give you an idea of the standard challenge that we have been dealing with for several decades already. Imagine a 120-story skyscraper. What we're looking for is the size of a coin in the basement. We cannot see down there. We have to measure by indirect measurements, and we drill to hit this target 120 stories further down. If we hit an obstacle on the way, there is no way to take the elevator down. And don't try to be smart and take the stairs, because they don't exist either. This is the standard challenge we have. To fuel the world and replace all the decline that we're seeing, we're basically assuming that we have found all the major oil fields in the world, or at least most of them already. They're already in production, and they're already declining. Saudi Arabia is very careful to not tell the world how much water they are producing per barrel of oil, but it's quite significant, and it's increasing. We need to find challenges that are, or reservoirs that are smaller, more complex. When this is the standard challenge we're facing, you can imagine what more complex and smaller looks like. Now, a more realistic image of the situation is represented here. Here you see basically oil and gas is generated over millions of years with sediments accumulating typically on the bottom of an ocean, building up to kilometers of sediments. And today we're coming in through sound measurements emitted from the surface, measuring reflections, echoes from the subsurface. That's the best image we have. We put wells in here to understand what's down there and get the oil and gas out. We put facilities on the surface, either on land or offshore on platforms or even on the seabed. Valves, pumps, measurements, and so on. We are already having several of our major clients dealing in the exabyte scale with data. And more data is coming on as we are instrumenting Internet of Things and so on, are instrumenting all these devices that we have in the oil field. Our friends at Google say that we do not have a data-rich problem, we have a data-overwhelming problem. To address this problem, we decided to disrupt ourselves. We have been the leaders in the software industry, in the oil and gas business, for a good number of years in Schlumberger. But we saw the opportunities that digital will bring to the oil and gas industry. 2 years ago, we launched our answer to this, the Delphi cognitive environment for exploration and production. This was a major shift in our technology. We used to be an on-premise software provider. Now we are operating in the cloud, as many of you in the room here are experiencing as well. And our clients are incredibly nervous about the data security. So the first and foremost requirement was that this environment had to be secure. We had to change the way we work. And as one of the few players in the oil and gas industry, we have achieved SOC 2 Type 2 accreditation. We built the environment to be cognitive, to combine the best of the human and the computer and let the computer learn from the human interactions. And we designed it to be personalized so that a reservoir engineer, a geologist, an operator in the field, and the executive of an oil company will have a view which is tailor-made for them, but still contributing to the same truth. And we have made major achievements with this. In processing the images that we get when we're trying to get a view of the three-dimensional structure under the surface, we call that seismic, basically sound pulses that we send down and get back. We have taken the big jobs down from 13 months to 2.5 months. In evaluating number of scenarios for developing fields, we are now able to evaluate 14 times the number of scenarios 3 times faster. That 14 times multiplied by 3. And our reservoir engineers, or our industry's reservoir engineers, are able today to complete their work not in 120 days, but in 3 days. However, we had to address one fundamental challenge. The people, the targets, our users, if you like, are geologists, geophysicists, reservoir engineers, mechanical engineers, operators in the field, and so on. They're coming out of university or education system defined in silos by the educational system. And we have, for decades, been providing software to these users which are adhering to those silos. To solve the increasing challenges we have in our industry, we really need to get collaboration going across the discipline. We need to break down these silos. And we see openness as a key component in this challenge. We see openness in order to liberate our workflows out of confined applications for the individual silos and liberate the data out of the similar constraints. As one key contribution to achieve this liberation, last week we started open sourcing a core component of the Delphi environment, the Delphi data ecosystem, so that the entire industry can work towards one view of the data for the subsurface and the surface facilities. Our customers are oil and gas companies, it's the BPs and the Shells and whatever. They are in a fierce competition for the same resources against each other. they need to be able to differentiate. So we have designed Delphi to have the ability for our customers to add their own intellectual property and differentiate against their competitors. And we embrace openness in order to connect the best technology of the world. And this is where we partnered with Tibco to bring in the Tibco leading analytics platform that you're all very familiar with in this room, of course, together with our domain science. So domain science are all the physics-based simulators and methodologies that map the subsurface and simulate what's going on over millions of years as hydrocarbons are formed, over weeks and years as we are producing the oil fields, and as the oil is flowing through the wells and the pipelines and through the facilities towards where you all can consume it. And that's why we combined in this our basic first principles physics simulators and first principles physics technology, if you like, with the Tibco technologies. We have established ourselves, as I said, as the market leader in the oil and gas software space. But we saw that we really had to cannibalize that position in order to drive the industry forward. We had to disrupt ourselves. Together with Tibco, through an open mindset, we are driving the energy industry forward to be able to address, to be able to supply the energy the world needs, to be able to keep your lights on, to be able to enable millions of new people to get their lights on, and to enable you to power your data centers. Thank you.